afternoon, students. How is everyone doing? I hope by now you all are ready to actually solve some questions. Now we have completed all the syllabus that you will need to solve almost every one of these PYQs. So are you ready? You will solve it first. You will try each one of them. I will give you around 1 minute to solve it on your own, and then I'm going to share the solution. You can check your answer, you can check the way you solved it, and if you solved it in a way which was more efficient, then required less number of calculations or something like that than what I showed, then definitely message in the chat so that I can learn something from all of you brilliant students. So are you ready? Alright, so the flow of PYQs, I have divided the PYQs into two parts so that we can do it in two separate sessions and not all of them at once. And of course, we're not going through all of the PYQs, right? Because they are repetitive, they might be too easy for you, something that we have already covered in previous lectures. So that is why I have selected the questions that will be helpful for you, that might help you learn how to actually apply whatever we learned so far. And before anyone comments, ma'am, please Hindi. But this is an English only course, so we will bring a Hindi English course, however you feel comfortable later. But as of now, this is a purely English course for the students who are not that comfortable with Hindi. Alright, so we start with KVPY PYQs. A lot of letters there, KVPY PYQs. But yes, we start with KVPY questions related to combinatorics that I feel have been very good, have been very difficult, and then we move on to PRMO, before IOQM even started, because the questions, the syllabus is pretty much the same, right? The level of questions is pretty much the same. So we're going to go through PRMO, and then in the next session we are going to cover more PRMO questions as well as IOQM PYQs, the ones that have been asked ever since IOQM started. Okay, so we'll try to cover as many questions as we can in these two sessions so that all kinds of questions have been visited, all kinds of approaches have been learned. You can attempt a new problem on your own if you are able to solve all of these questions. Okay, so keep your minds sharp and open. Do not be lazy. Try to think of the solution from any direction and every direction and get the right answer as quickly as you can. Now, so a woman has 10 keys, out of which only one opens a lock. She tries the other keys one after the other, keeping aside the failed ones. She takes one and tries to open a key, and if it doesn't work, then she puts it aside. What is the probability that she succeeds at the 7th key? She's trying 10 keys one at a time, and if it doesn't work, she just discards it. So what is the probability that the 7th one that she tries is the right one? Only one of them is going to be right. D. Very good. So the answer is D. This one does not require any calculations. This is just using your brain, just thinking of it logically. So there are 10 keys. It doesn't matter in what order. If you have key 1, key 2 up to key 10, what is the probability that this one, key 7, is the right key? Same as the other one. There's nothing special about the 7th one, right? So that means it's 1 by 10, 1 by 10 for each of them. So the correct answer is D, 1 by 10. Okay. Yes, to answer the question in the chat, will IOQM 2023 PYQs be also there? Yes, but all the recent PYQs will be covered. I will select the questions that I feel have not been covered yet. It will help you learn something unique. So those are the questions I will handpick. I will not cover the entire IOQM papers. maybe in another session, but in these 2 sessions I will select the PYQs that I feel are different, are unique, that are going to help you learn a new approach. Okay, now next question. S is a set of first 40 natural numbers 1 to 40. Let A be a subset of S such that no 2 elements in A have their sum divisible by 5. What is the maximum number of elements possible in A? For example, if I have 1, 4, 7, if A is this, then that is not allowed. Why? Because no 2 elements in A should have their sum divisible by 5, and in this case 1 plus 4 is 5, which is of course divisible by 5, so this is not allowed. Think carefully. Yes, 17 is the right answer. C, yes, very good. So how do we approach such a problem? That is more important than what is the right answer, right? So yes, the correct answer is 17, but how do we get that? We have 40 numbers. Out of 40, 8 of them are divisible by 5. 8 of them will leave a remainder 1. 8 of them will leave a remainder 2. 8 will leave 3. 8 will leave 4. And divisible by 5 means 0. So in terms of remainder, we are going to check if we take any of these numbers and check its mod with respect to 5, what will be the remainder? It can be 0, 1, 2, 3, 4, and because there are 40 numbers, there are exactly 8 of each of these. 8 numbers which will leave remainder 0, 8 that will leave 1, 8 that will leave 2, 8 that will leave 3, 8 that will leave 4. Now, if I take any 2 of them, any 2 out of these 8, any 2, then their sum will be divisible by 5, right? Because one of them is divisible by 5, the other one is also divisible by 5, then their sum is also divisible by 5. For example, if I take 15 and 25, then the sum 40 will also be divisible by 5. So at max, I have to check the maximum number of elements. So at max I can take 1, right? Because if I take 1 out of these, then I do not have to worry about the sum being divisible by 5. Now coming to these 4 categories, if I take 1 from here, 1 from here, then this leaves a remainder 1, for example 11. This leaves a remainder 4, for example 19. 11 plus 19, 30, that will leave a remainder 0. The sum will be divisible by 5. So I can not take 1 from here and 1 from here. Even if I take, let's say 8 from this second category where remainder is 1 and just 1 from the last category, even then I will find 2 elements whose sum is divisible by 5, which means either I can take the elements from here or I can take the elements from here. But out of these 16, at max I can take 8 either from here or from here, but can't be from both. So out of this I will get 8. Similarly, but the same logic from these 2 as well, I can take either all 8 from here or 8 from here. Of course I can take less than 8, but I am checking the maximum number of elements possible. So 8 from here, 8 from here, 1 from there. So 16 plus 1, answer is 17. Okay, so this is how we will actually calculate. Now, how many ways are there to arrange the letters of the word education so that the following 3 conditions hold? There are 5 vowels. All of them should occur in the same exact order. We cannot have A before U or anything like that. We can have something in between these, but when we just take the vowels, this order has to be maintained. obtained. The consonants also occur in the same order. The 4 consonants, there are 5 vowels and 4 consonants. These 4 also have to maintain their order. And no 2 consonants are next to each other. Gap method. So, what's the answer? Carefully. The vowels have to occur in the same order. The consonants have to occur in the same order. And the most important, the thing that we know how to solve this, right? That no 2 consonants are next to each other. What do we do in that case? Come on, come on, come on. Yes, we'll be covering all sorts of problems in these 2 sessions, in IOQM and PRMO and KVPY, all the combinatorics problems, because they are all relevant for you when you're preparing for IOQM and other related exams. So we are going to cover all of such unique problems, not the easy ones, of course. I know you can do that, but yes, we'll be covering all categories of problems. Okay, no, D is not the right answer, but you try again. Think carefully. Maybe you're missing one of the conditions. I'll give you 10 more seconds and then don't guess. Yes, A is the right answer, but I hope you're not guessing. So how do we actually do this? We have, so the answer is A, by the way. So the one student who got it right, yes, it is correct, but I hope you were not guessing and you were actually thinking of it logically. So this is a very easy problem, but this is using all the concepts that we have done already. Very easy. Let's see how. So the third condition, no 2 consonants are next to each other. What does that mean? That means that, how do we do that? We first place the vowels and between those gaps we place the consonants to make sure that no 2 consonants can be together. Right? This is what we did. So first we have to place the vowels. Ideally we would have done 5 factorial, but now we know the order. So there's only one option, I, U, A, I, O. And my vowels are placed, my vowels are ordered because there's only one order allowed. Then we have to place the consonants, right? So first what did we do? We picked 4 places out of these 6 for the consonants. So 6C4. And then we arranged the consonants. But here again the order is fixed. So once, let's say we pick this one, this one, this one and this one. Let's say we pick these 4. Once I picked it, I have my word, I have my arrangement, because the order is fixed. It has to be D, C, T and N. And that is my arrangement. So in total, how many ways to arrange? Just 6C4 or 15. Okay? Think carefully, very logically, do not have to memorize any of it. Just learn how to approach all sorts of problems correctly. Okay? Now, let A1, A2 up to AM be non-empty subsets of this given set which has the first 100 natural numbers. They satisfy the following conditions. These M subsets are satisfying these conditions. What are these conditions? This number of elements, this is number of elements in A1, number of elements in A2, number of elements in AM. They're all distinct. It's not possible to have 2 subsets which have the same number of elements. And another condition, they are pairwise disjoint. They don't have anything in common. Any two. Take any two of these subsets and they will have nothing in common. That means we have to essentially partition this 100 into different. Why partition? We can, of course, it doesn't say that we have to use all of the natural numbers, all of the 100 numbers, right? Of course, we don't have to, but we have to find the maximum possible value of m. So we have to have the maximum number of subsets. So in a way, yes, we are trying to partition it, or we're trying to partition this so that we get maximum subsets which are unique, which don't have anything in common. If one of these elements, one of these natural numbers, let's say 7, is going into one of the subsets, then we cannot put 7 into any other subset. Okay? And the number of elements in each of them will have to be different. So what is the answer? 13, 14, 15, 16. Which option is correct? A, B, C or D? Try again. Say yes. A is correct. 13 is the right answer. Very good. Yeah. So for all those students who are getting another answer, just recheck your solution. Think of it. What are you missing? What are you counting? What are you missing? What are you skipping? What are you recounting? In combinatorics, that is what you have to learn. Don't just check the solution what ma'am shares, but actually go through your solution. Where did you make the mistake? That is how you learn. That is how you get better. Trust me, if you're not doing that step, if you're not analyzing your own solution and checking what went wrong, or whatever you thought of, will that give the right answer or the wrong answer? And why is it giving the wrong answer if it is? All of these analysis, all of these questions really help you expand your mind, really help you just be better at maths. Trust me, that is how you're supposed to learn maths. Now coming back to this, so answer is A. Let's see how. We have all of these are distinct numbers, right? The number of elements in A1, the number of elements in A2 and so on. Let's assume this is an increasing order. We can take it in any order. So let's assume, without any loss of generality, that A1, A2, Am, they are all, the number of elements in each of them is distinct and increasing. Now we have to maximize the number of subsets, which means we have to minimize the number of elements. If I take 10 and then 40 and then 70, then I will get very few. But if I take 1, 2, 3 smaller elements in each subset, then I will get more number of subsets, right? So we start with 1. Now this cannot have one element, so we will have the next smallest number 2, then the next one will have the next smallest number 3 and so on. So that means the minimum way of doing it would be something like this, right? Now the total number of elements in this will be 1 plus 2 plus 3 up to m, or m plus 1 by 2. This total elements has to be less than equal to 100. Right? Because we're taking some here and then some here and then some here and then some here and so on. So the entire sum cannot be more than 100 because we're not repeating any number. We cannot repeat any number. So the total has to be less than 100. Now we will just solve this. M plus 1 is less than equal to 200. Now this is an increasing value, right? As m increases, this sum will increase. So we have to find the largest m. for which this is true. Of course, even for m equal to 1, this is true. 1 into 2, 2 is of course less than equal to 200. But we have to find the largest m for which this is true. So let's check 13. 13 into 14, what is that? 13 into 14 is 2, 13 plus 5, 182. So this satisfies. We move on to the next one. 14 into 15. What is this? 14 into 15, 7210. This does not satisfy, which means the largest m that is satisfying this condition would be 13. We cannot have 14 or higher. After that, this will not hold true. This inequality will not hold true. So 13 is the highest number for which this inequality is holding true. Okay? So this is how you do it. This is how we can maximize the number of elements, the number of subsets. We have to minimize the number of elements in each of them so that we get as many subsets as we can. Okay? Next one. If a 3-digit number is randomly chosen, what is the probability that either the number itself or some permutation of the number, which is again a 3-digit number? Why is it saying which is a 3-digit number? Because, for example, if we have something like 970, then one of its permutation can be 079, but now this is a 2-digit number. So we are not going to consider this permutation. We are only going to consider the permutations which remain a 3-digit number. Okay? So that at least one of the permutation of it should be divisible by 4 and should be divisible by 5. Both. It should be divisible by 4 and by 5. So what is the probability? How many, first of all, how many such numbers are there that either that number or its permutation is divisible by 4 and 5. You check that and then divide it by total number of 3-digit numbers that we have, and you will have your probability. So try this one. Yes, B is correct. I hope again you're not guessing, but yes, B is correct. Very good. That's amazing. Let's see how. First of all, let's see how do we approach such a problem. That is what we're here to learn, right? We're not just here to solve some problems. I know you are having fun solving these problems. I am also having a lot of fun, but it's very important to learn how do we learn how do we check which method should we use here. So let's understand the question. The question says that the divisibility by 4 and 5. The number should be divisible by 4 and by 5. That means it should be divisible by 20. Only in that case is it possible that the number is divisible by 4 as well as by 5. Right? We have to find the LCM of the two numbers, and that is how we check the divisibility. So first of all, that should be clear. Then we are saying that number of such numbers which have a permutation which is divisible by 20. So let's do it in the opposite order. We first find all the numbers that are divisible by 20 and then check all their permutations, as long as they remain a 3-digit number, right? So first we check how many numbers are there that are divisible by 20. Then we check their permutations, all possible permutations, and that is how we'll find the total number of numbers that have some permutation, either themselves or some rearrangement, as long as it remains a 3-digit number, that are divisible by 20. So let's start. Now what is the first? Okay, first of all, how many 3-digit numbers do we have? It starts from, what's the smallest 3-digit number? 100. What's the largest 3-digit number? 999. So total is 999 minus the one before this, 99. Out of the first 999 numbers, we are removing the first 99 numbers. So total 900. That is the total. So in order to calculate the probability, this will be our denominator. That we are done with. Now, out of these 900 numbers, first of all, let's check what are the numbers that are divisible by 20. What's the smallest number that is divisible by 20? 100. Then 120 and up to the last one will be 980. Because after that we get 1000, which is a 4-digit number. So like this we have our numbers that are divisible by 20. But now we have to calculate how many permutations we can have. We can't just say 3 factorial or 2 factorial or anything like that, because it can have a repeated digit or it can have all distinct digits. So we have to check. Okay. So let's first of all be very clear about one thing. What is that one thing? That the last digit of all of these numbers is going to be 0, because 20 is able to divide all of these numbers. They are all multiples of 20, which means the last digit has to be 0. So we have at least 1 0 here. Right? Now, let's say we divide it into different categories. First is all 3 distinct digits. Right? Like 120, 980, all 3 are distinct. Last one will be 0, but the other 2 are non-zero and different from each other. Then we have something like 100, where we have 2 zeros, right? So some non-zero digit followed by zeros. That will be one category. All 3 digits cannot be same. We have 3 distinct and then 2 can be same, but all 3 cannot be same because last one is 0 and the first one cannot be 0. Now another category is there where these 2 are the same and this is a 0. So whatever non-zero digit we have, it's repeated and the other one is 0. Right? Let's look at it one by one. How many such numbers are there and how many permutations are possible for each of them. Okay, so let's look at it one by one. First of all, we have 3 distinct, or rather let's see how many permutations will be there for each of them. Okay, so for 3 distinct, we have something like, let's say 1, 2 and 0. Then for the first position, we will have 2 options out of the 2 non-zero numbers. Then for the second one, we'll have 2 remaining because now 0 can also be here. And then the last one will be 1. Right? If we have to find the number of arrangements of such a number, 120, then how do we calculate? There are 2 options for the first one, either 1 or 2. And then once we have placed the non-zero, then either here there will be 1 non-zero or 0 and whatever is remaining will be here. We are counting the number of permutations possible of such a number. So here we have 4. Here we cannot have any other arrangement. Why? Because this has to be non-zero, so 0 cannot come here. So only one arrangement is possible of such a number like 100. Now here when we have both of these same, now let's say for example, for easier understanding, we have a number like 220. This is divisible by 20, right? So 220 is such a number. How do we find all the permutations? For the first place, only 2 is possible, right? 0 cannot be here. So for here we have one option. Now once we have placed 2 here, now here either it can be 20 or 02. Right, so we have 2 options for this and 1 option for this. So total 2 permutations are possible, either 220 or 202. So we'll count both of them. So this is how we will calculate the number of permutations possible for each category. These are all the categories. All we need to do now is count the number of all such numbers. Okay. Again, very logically, we have let's first check the second category. This is the easiest. We have 100, 200, 300, all of them will be divisible by 20. So we will go from 100 to maximum 900. So total 9 possibilities for this digit. So total we have 9. So from this category we get 9. From this category, in order for this to be divisible by 20, this digit here, this tens digit has to be divisible by 2. It has to be an even number. If it's not, let's say 130, then it's not divisible by 20. So that means we need to have an even digit here, and these two are the same. So that means either this can be 220 or 440 or 660 or 880, right? That's all that is possible. 110, 330, they won't be divisible by 20. We need these two digits to be the same. So either 2, 4, 6 or 8. Non-zero even numbers are 2, 4, 6 and 8, non-zero even digits. So 4 options for this, total 8. So now, how many total numbers were there that were divisible by 20? 20 into 5, 20 into 6 up to 20 into 49. So from 5th multiple to 49th multiple, total 49 minus 4, 45. So total we had 45 multiples. Out of them 9 and 4 have been considered, 13 have been considered. So remaining 32 will have all distinct digits, right? So this becomes 1 to 8. So what are the total numbers that are divisible by 20 or the permutation is divisible by 20? 128 plus 9, 137 plus 8, 145. So the probability will be 145 by 900 or 29 by 180. So this is how you calculate all the permutations, whatever has been asked in the question. Okay. Another way of calculating how many such multiples of 20 are there such that this is, all of these are distinct. We can do that. How can we do that? We have to find number of multiples of 20 which have all distinct digits. So first of all, this has to be 0. Now this has to be an even number but not 0. Otherwise it won't be distinct. So it can be 2, 4, 6 or 8. 4 options. Now out of 10 digits, 0 has been taken and anyway this had to be non-zero. So out of the 9 non-zero digits, 1 has been chosen here. Now out of the remaining 8 we can take any, but we cannot take this one again because otherwise it won't be all distinct. So out of the remaining 8 we can take any one. So for this we have 8 options. So total 8 into 4, 32 options. So you can either count all of them and subtract these two, or you can check how many multiples of 20 are there that will have all distinct digits. Okay. Try this one now. We have a set A which has all the first 30 natural numbers. Number of ways in which one can choose 3 distinct numbers from A such that the product of the chosen numbers is divisible by 9. Why was it 2 into 2 into 1 in the previous question? Because if we have to calculate the number of arrangements of, let's say, a number like 980, how many 3-digit numbers can we make using 9, 8 and 0? That's the question. I know you can solve it. The number of 3-digit numbers we can form using 9, 8 and 0. The first one, the 100th digit, will have two options, either 9 or 8. Then once we fix that, the 10th digit will have two options, 0 and a non-zero number, and the remaining third digit will go in the ones place. So total 2 into 2 into 1, 4 options, 4 ways of arranging. Okay, C1110. Try again. It's a tricky one. Yes, this problem is not trivial. Just give it a try. 1590. That is perfect. Very good. Let's see how. So first of all, we need to find 3 numbers. There is no order. We just need to select 3 distinct numbers from this set such that their product is divisible by 9. In order for this to be divisible by 9, we need to have at least 2 3's in the product, right? Either we can have something like 9 into 2 into 7, we get 9 from here, or 18 into 2 into 7, something like that, that we have at least one multiple of 9 here. Or we can have something like 3 into 6 into 5. Now we get 1 3 from here, 1 3 from here, and the product will have 2 3's or will be divisible by 9. But something like 3 into 7 into 1, this doesn't have 2 3's, this only has 1 3, so it won't be divisible by 9. Or let's say we have 3 into 27 into 6. This has all the 3's, right? We get 1 3 from here, 3 3's from here and 1 3 from here. This will be divisible by 9. Why? Because we only needed 2. We can have more and that's fine, but we need at least 2 3's for this to be divisible by 9. Or if there is no 3 here, no 3 here, no 3 here, no 3 here, again won't be divisible by 9. So that means it can have as many 3's as it can in the product. The power of 3 can be anything, but we need at least 2. So, and one way to approach this is you check total selections and exclude the one that we don't want. What do we exclude? Either there was 0 3 in the product, or there was 1 3 in the product. As long as there is 2 3's or more, then it will be divisible by 9. So the remaining are good to go. These 2 categories are something that we don't want. So this is how we are going to go. Let's see one by one what are these numbers. Total selections, out of 30 we are selecting 3. So 30C3. 0 3's. Now we need to check how many multiples of 3 are there, how many multiples of 9 are there, and so on. So multiples of 3, 3, 6, 8, 3, 6, 9, 12 and so on, right? So from first multiple till the 10th multiple, basically 3's computation table, right? 3 into 1, 3 into 2, 3 into 10. So first 10 multiples are here. So we have 10 multiples of 3. But we cannot just say, so okay, first of all, till here for this category we have 10 multiples of 3. That means the remaining 20 have 0 3's, right? For example, 5, 11, if it's not divisible by 3, then it won't give any 3. So the remaining 20, we have to select 3 out of these remaining 20 and we'll have 0 3's. Now in the last category, we need exactly 1 3 in our product. If I select any one of them, any one of these 10, then I can also select 9, and in that case I will have 2 3's, or I can select 27, I'll have 3 3's. That is not allowed. So basically we have to choose the numbers which are not divisible by 9 out of these 10. So what are the numbers that are divisible by 9? 9, 18 and 27. Other than these three, if I take any of these remaining 7, so there are 3, so we are left with 7 multiples that give 1, 3, right? So if it's 3, 6, 12, all of the remaining multiples will give exactly 1, 3. So in this category, we have to select exactly 1 out of these 7, and for the remaining 2 numbers, we have to select out of those 20, right? Because we need exactly 1, 3. So 1 from these 7 and 2 from the remaining 20, and that will give you the final answer. You can calculate 30C3, that is 30, 29, 28 by 6, 20, 19, 18 by 6, and this is 7 into 20, 19 by 2, 10. So we can calculate this way. 30C3, that is 5 into 29 into 28. Okay, a lot of calculations there. 140 into 29. So 14 into 9, that is 126. And 28 plus 12, that's 4060, right? And then we have 57 into 20, so that is 1140. And we have 7 into 19, that's 133, so 1330. So 2470, 4060 minus 2470, that is 1590. Yes. So option A is correct. Okay. Alright. So this is how we approach such a problem. We check. Again, if you remember from one of our lectures, we saw we can also calculate that we have 2 3s or more 3s like that, right? We have 2 3s from different multiples, or we have 2 3s from the same number, like that. We can also calculate it using that method. That is also fine. You should try. If you thought of that method, you should definitely try, and you should get the same answer. But you have to just see whichever you think is easier, less complicated. You should go with that. All right. Now, let M respectively and N. So M and N are the number of 5-digit integers that are obtained by using the digits 1, 2, 3, 4, 5. Okay. So we have 5 digits 1, 2, 3, 4, 5. M is the number of 5-digit integers we get with repetition, and N is the number of integers we get without repetition. The condition for both of them is sum of any 2 adjacent digits is odd. Then M by N is equal to, try it once. Check your answer again, bache. Yes, 15 is correct. Very good. Let's see how. This is an easier question, I think. All you need to remember, all you need to understand is sum of any 2 adjacent is odd when our When is the sum of two digits odd? When one of them is even and the other one is odd. If both are odd, the sum is even. If both are even, the sum is even. So one of them has to be odd, the other one has to be even. Which means it always, any two adjacent. So that means it always has to be alternate. Let's first check what n is. For n, we need to rearrange these because repetition is not allowed. We need to form a 5-digit number. So that means we have to rearrange these 5 digits here such that it alternates between even, odd, even, odd. We have 3 odd, 2 even. So the only possible way is we get odd here and even here, right? So that means we have how many options for odd? 1, 2, 3. 3 options for odd here, then 2 here and 1 here. Or you can say we find an order of odd digits, we find an order of even digits, and that is 3 factorial into 2 factorial. So the answer is 6 into 2, 12. Or you can do it this way, that we arrange the odd ones. Now for the even ones, we have 2 options here and the remaining 1 option here. So 3 into 2 into 2 into 1 into 1, 12. So n is 12. We have our n, which is 12. Now we need to find m. For m, repetitions are allowed. So now, same as before, now there are 2 options. Either odd goes first. So odd, even, odd, odd. Or we have, it starts with an even digit and then we have even, odd, even, odd, even. Now repetitions are allowed, so we have as many options as we can. So now we're not limited that, oh, we have less even, so even cannot start first. But here repetitions are allowed, so even can also start the number or odd can also start the number. Now for odd case, we have 3 options. So 3 options, then 2 options, then again 3 options, because repetitions are allowed. Then 2 options, then 3 options. So we have 3 cube into 2 square. And here we have 2, 3, 2, 3, 2. So total 2 cube into 3 square. We add these two. So m comes out to be, if we take 2 square, 3 square common, we have 3 plus 2. So 4 into 9, 36 into 5, that is 180. So m comes out to be 180. 180 divided by 12, 50. Okay. Let x1, x2 up to x11 be 11 distinct positive integers. Okay, we have 11 distinct positive integers. Now we replace the largest of these integers by the median of the other 10 integers. Then what happens to the median? What happens to the mean? Does the mean increase? Does the mean remain the same? Does the median remain the same? Does the median decrease? Which of them is correct? It's very logical, very based on understanding. Yes, it's fun, right? These questions are super fun. Just very easy. You don't have to memorize anything. You just have to think. That's all. So, which of them would be correct? B. Try again. See, median decreases. That is amazing. Perfect. So, let's see how. Without loss of any generality, I am going to say that the first 10 are smaller and this is the largest. Basically what I am doing is I am arranging them, right? If you want, you can arrange them and then number them A1, A2. If you have a little bit of confusion, then let's say I arrange them, these 11 distinct numbers, such that they are in an increasing order. It's distinct, so they cannot even be the same. A1, A2, A3, A10, A11. Like this, I have them in increasing order. So that means A11 is the largest. What did we do? We replaced A11 by median of other 10. Median. Now they are arranged in an ascending order. So median of 10 numbers, median of even number of numbers will be the mean of middle number. So mean of two middle numbers, A5 and A6. So median of these numbers, A5 plus A6 divided by 2. Now I replaced A11 with this, and now I will arrange them again. So what will be the new arrangement? A1, A2, A3, A4, A5, and then this number A5 plus A6 by 2, and then A6, because it's the mean, it will be between these two, and up to A10. We again have 11 numbers, right? Now the total sum of the numbers will definitely decrease, right? The total sum, earlier we had A11, now instead of that we have a smaller number. This is much smaller than A11 because this is somewhere here. So that means the total sum of all numbers decreased. Number of numbers remained the same, so mean will decrease. So mean remains the same or mean increases? No, mean decreases. What about the median? What was the original median? The original median of 11 numbers was A6. For all of these, the median was A6 because it's odd number of numbers, so there was a middle term A6. Here again we have a middle term which is A5 plus A6 by 2. So earlier it was A6, now it is smaller than A6. So that means median decreased. And that is your final answer. Now, this is the last problem from KVPY PYQs, but it's a bit tricky again. So it is kind of like the one we did for 20, but a more difficult version of that problem. So do try this one. If you were able to understand that solution, then I think you can solve this one as well. Just make sure you're not missing any case. So let's go through the question. A denotes the set of all 4-digit natural numbers with no digit being 0. That means all are non-zero digits. B is a subset of A, which consists of all numbers such that no permutation of its digits gives a number that is divisible by 4. Just like before when we were considering multiples of 20, here it's just 4. Then the probability of drawing a number from B with all even digits. So we need the total number of numbers in B and the number of numbers with all even digits. Says answer is C, but I also showed you the answer, so I hope you were able to solve the question and not just sharing the correct answer. But yes, the answer is C. Is anyone else also getting the option C? Yes? Okay, let's see how it actually is C. So we need to understand how we can actually consider multiples of 4. This is very important. This theory can be used in various combinatorics questions. So we have to understand which numbers are divisible by 4. Of course, we know the last 2 digits have to be divisible by 4. That is something, the divisibility rule we all know, right? That means the first 2 digits can be anything. As long as the last 2 digits, this number is divisible by 4. Also, if it's divisible by 4, clearly it has to be an even number, right? The last digit cannot be odd because the number cannot be odd. So, this can be, in this case, non-zero. So, 2, 4, 6 or 8. Now, bache, whenever it's either 2 or 6, this number has to be odd. Whether it's 12, 32, 36, 56, all the numbers such that this tens digit is odd, the ones digit is 2 or 6. Then it's divisible by 4. But if it's even, for example 42, 46, they are not divisible by 4. So with 2 and 6 it has to be odd. With 4 and 8 it has to be even. 24, 44, 68, all of these are divisible by 4. So as long as this is even and this is 4 and 8, or this is odd and this is 2 or 6, then we will have a number that is divisible by 4. So I hope this is clear to everyone how to actually check divisibility, right? Now, we need to check how many numbers are there in the set B. How many numbers or their permutations are there which have divisibility, by 4, right? Now, how we will proceed this is, we are checking odd and even, right? So, let's see if all even digits are there, which is what the probability, which is what we have to calculate, right? So, all even digits. Now, if we have 4 and any other even digit, whether it's 2 or 4 or 6 or 8, we can form a number which is divisible by 4, right? Because with 4 or 8, as soon as we get one even digit in the number, we will have a number that is divisible by 4. So, for example, if we have 2, 2, 2, 4, then this is divisible by 4. And even if it is something like 2, 4, 2, 2, now 22 is not divisible by 4, but its permutation of the digits of this number will give a number which will be divisible by 4. So, what does that tell us? That tells us that we cannot have 4 or 8. When we are considering all even digits, as soon as we have even one of these, we do not have a number that is not divisible by 4, right? So, we need either 2 or 6 in all of the 4 positions. So, all even digits, we have 1, 2, 3, 4 digits, 2 or 6 here, 2 or 6 here. Of course, repetition is allowed. 2 or 6 here, 2 or 6 here. So, 2 raised to power 4, 16. So, these are all the numbers whose permutation is not going to give us a number that is divisible by 4, and it will have all even digits. Now, let's say it has all odd digits. Even then, we won't have any number that is divisible by 4, right? No matter which permutation we take, we will not have a number which is divisible by 4 because it has all odd digits, right? So, how many odd digits do we have? 1, 3, 5, 7, 9, 5 odd digits. So, 5 can come here and then 5 can come here. Repetition is allowed. So, total 5 raised to power 4, 625. Now, let's consider the case when we have one even digit and 3 odd digits. Now, let's think about it very carefully. If we have or 6. Okay, if that one even digit is either 2 or 6, then we can form a permutation where the last digit is that even digit and any odd number, any odd digit before that, and that will be divisible by 4, right? Because 2 and 6 need odd digits before them. So with 2 and 6 we have to have all even options so that no permutation is divisible by 4. So in that case only 4 or 8 are possible, and then 3 odd digits, that can be 5 cube. We have 5 options for them, right? So 5 cube into 2 options for the the even digit, and then we also have to find the arrangement, right? Where is this odd digit? Where is this odd digit? We find a place for that. Out of these 4, one place has been selected for the even digit and the remaining 3 are odd. Okay, so this comes out to be 8 into 125,000. Now what are the cases that are left? We can have 2 even digits, two odd digits. Now again, just like the previous logic, if we have 2 odd digits, then 2 or 6 cannot be there, because with one of the 2 or 6 and one of the odd digits, we will form a number which is divisible by 4. So 2 or 6 cannot be there. How about 4 and 8? 4 and 8 can also be there by this logic. If 4 and 8 gets another even digit, which it has because there are 2 even digits, if we place 4 or 8 here and then any other even digit here, then we get a number which is divisible by 4. So this case is not possible. Similarly, 3 even digits are not possible by the same logic. Even if we have one odd digit, 2 or 6 cannot be there, and if we have 3 even digits, even if we have 2 even digits which are, and one of them is 4 or 8, then it will be divisible by 4. So these cases are not possible. So the total is 16 plus 625 plus 1000, and numerator will have 16. So 16 divided by 16 plus 625 plus 1000. That will be your answer, which is 16 by 1641. Yes, bache, class 10 students can totally understand this, but you have to go through the lectures. If you haven't studied the theory, then I recommend that you go through the 10 lectures that we have done before this, and this is using all of the concepts all together. Okay, so this is how we count the total number of permutations where we can find one of the permutations which is divisible by 4 or not divisible by 4, right? So this is a very important question. This is a very good question to help you understand all possible arrangements, all such questions. This is, I think, a very good question. So you should definitely revise this. You should have this in your notes whenever you revise your theory. This question is a good one. It will help you understand a lot of concepts at one place. Okay. Now let's do an easy one. We have done a few tricky ones. Let's take a break from the difficult ones and let's do an easy one right now. So find the number of ordered triplets A, B and C of positive integers such that their product is equal to 108. Yes, what's the answer? Quick. Yes, beg a coin, but what's the answer? Yes, there will be another lecture like this. We won't be able to cover all the PYQs, all the important PYQs in just one session. So yes, there will be another one very soon. I will announce it on the channel when I will be taking the next one. 60, that is correct. Very good. So let's see how we get this. we have, first of all, let's find the prime factorization of 108. It is 2 raised to power 2 and 3 raised to power 3, right? 4 into 27, that is 108. Now we have to find A, B, C, 3 numbers such that A is 2 raised to power x1, 3 raised to power y1. If we have any other prime number here, then the product will not be equal to 108, right? Now these numbers can be 0. It is possible that it only has 3, it only has 2, or none of them. 1 is also allowed, but it has to be only powers of 2 and 3. Similarly, 2 raised to power x2, 3 raised to power y2 for B, and C is equal to 2 raised to power x3, 3 raised to power y3. When we multiply these, we get 2 raised to power x1 plus x2 plus x3, 3 raised to power y1 plus y2 plus y3. This has to be equal to 2 raised to power 2, 3 raised to power 3, which means this is our multinomial problem, where x1 plus x2 plus x3 is equal to 2 and y1 plus y2 plus y3 is equal to 3. x1, x2, x3 can be 0, 1, 2, y1, y2, y3 can be 0, 1, 2, 3. Standard problem, we can use the formula directly. N plus r minus 1 Cn multiplied by n plus r minus 1 Cn. So 5 minus 1 4 C2, 6 minus 1 5 C3, 6 into 10 60. That is your answer. Yes, bache, it is possible that some of the questions are very easy. Yes, so I have only picked the hard ones mostly, but yes, this is an easy one just to show it to you that it is not always very difficult. Not every problem is going to be very difficult, especially if you have practiced all such questions, then you will find more and more problems easy, right? The more you practice, the more you will be familiar with such questions, and you'll be like, yeah, this is something I have done, this is something I know, this is so easy, this is so basic, I know how to approach this. So with practice, you will find more and more questions super easy. Okay, now let's try another one. A postman has to deliver 5 letters to 5 different houses. Mischievously, he posts 1 letter through each door without looking to see if it is the correct address. He just randomly posts a letter anywhere. There are 5 letters, 5 houses. He knows, okay, these are 5 houses. I have to send my letters to these houses, but he doesn't care where the letter is going, and he's just posting them randomly. Now delivering them randomly. I mean, how many different ways could he do this? What is the condition? Such that exactly 2 of the 5 houses receive the correct letters. Derangement, yes. What's the answer? C2 into D3, perfect. Very good. So, we have to first find which 2 houses get the right one, right? There are 5 C2 ways of selecting the 2 houses which get the correct letters, right? So, we have to find which 2 houses get the correct letters. Now, out of the remaining 3 houses, we need to make sure that they don't get the letter they were supposed to get. Anything else is allowed, but the letter that was supposed to go in these 3 houses, that is not happening, which is nothing but derangement. So D3. So 5C2 into D3, which is 10 into 2, 20. If you don't memorize D3's value, that is also okay, bache. D3 is 3 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. So this is 6, 1 minus 1 plus half minus 1 by 6. This is 0. 6 into half 3 minus 6 into 1 by 6 1, 2. So 10 into 2, 20. That is your answer. Easy again. So just have to understand these questions. They are not very difficult in a lot of these cases. This is very trivial. Just have to think how to actually count all possible cases. There are n. This one is also easy. We are going to do more difficult ones by the end of this class. Yes, there are some tricky ones in pre-RMO PYQs as well, don't worry. And we will be doing a lot more trickier ones in the next class from pre-RMO as well as from IOQM. Okay? Now, let's take a look at this one. There are n minus 1 red balls, n green balls, n plus 1 blue ones in a bag. The number of ways of choosing 2 balls from the bag that have different colors is 299. What is the value of n? Quick. I'm waiting for your answer, bache. This one's an easy one. Come on. Perfect. Easy, right? So we have to select 2 balls out of these 3n. Total n minus 1 plus n plus 1. We have 3n different balls and we have to select 2 balls such that they have different colors. So either it can be RG or GB or RB. Right? These are the 3 options for 2 different colors. Now for RG, we have to select 1 from these n minus 1 and 1 from these n. Or translates to plus. If it's an or, then we have to add. GB n into blue n plus 1 plus R into B, that is n minus 1 n plus 1. This is equal to 299. That's it. Now it's easy. We take n common out of these 2 and n minus 1 plus n plus 1 becomes 2n plus this is n square minus 1 is equal to 299. This comes out to be 2n square plus n square, 3n square minus 1. So plus 1 is 300. N comes out to be 10. Now, to each element of the set S, so S has first 1000 natural numbers. Now, we are assigning a color to all of these 1000 numbers. Okay, we have to assign some color to each of them. Now, what is the condition? The condition is that if for 2 numbers A and B, if 15 divides A plus B, that means A plus B is a multiple of 15. 0 is also a multiple of 15, even though 0 is not possible. 15 is also a multiple of 15 and so on. So, if 15 divides A plus B, then they are both assigned the same color. If A and B, the sum of A and B is a multiple of 15, then they have to have the same color. There is no other condition. Now we have to see the maximum possible number of distinct colors that we need to use. Seven or eight? Decide. 8. 8 is the right answer. Very good. So, just like before, we have to check the remainders, right? When we were checking the sum is divisible by 5 or not, it's the same way for the numbers. What are the possibilities for remainders? Remainder can be 0, 1, 2 up to 14. Now, each of these numbers which are divisible by 15 themselves, right? 15, 30, 45, all of those numbers will have the same color. Why? Because you take any two of them and their sum will also be divisible by 15. So, they have to have the same color. So, there will be one color for this category. Now, whichever color this category gets, any number in this category will have the same color as this category because their sum will be divisible by 15, right? So, for example, leaving a remainder 1, that is something like, let's say 1, and leaving a remainder 14, let's say 29. So, 1 plus 29, that is 30. So, their sum will be divisible by 15. So, we have to give the same color to these two. So, a maximum one color can be used for both of these categories. Take any number from here, any number from here, and they have to have the same color. So, that means all of these numbers will get the same color. Similarly, all of these will get the same color and so on. So, these are 14 categories. How many pairs can we make? 14 by 2, 7. So, 7 into 1 plus 1 for this one. So, 7 plus 1, 8 is the right answer. What is the number of ordered pairs A and B where A and B are subsets of 1, 2, 3, 4, 5 such that neither A is a subset of B nor B is a subset of A? We have to remember ordered pairs. So, order matters. It's not just that we are selecting two subsets. We are checking which subset is first and which subset is second. $570, yes, that is the right answer. Good. So, let's see one of the ways to do this. Number of ordered pairs A and B where A and B are subsets. Okay. So, what do we have to check? We are checking let's say A has 0 elements. That means A is 5. Then out of any of these we can have a subset, right? So, out of any of the remaining ones, see, there are two ways of doing this again, either using the direct approach or the exclusion approach. What we can do is we can check the total number of subsets that are the total number of ordered pairs that are possible. How many total subsets can we have for this? 2 raised to power 5, that is 32. So, 32 options for this, 32 options for this, total 1024 options are there. We are going to exclude the cases where A is a subset of B or B is a subset of A. One of them is a subset of each other, right? So, if A has 0 elements, we took some 0 elements. Of course, there is only one way of forming such a subset. Now, B has to come from its subset, right? B has to, let's say if B is a subset of A, then out of these 0 elements, A has to be one of the, B has to be one of the subsets of A. Similarly, if A has 1 element, then 5C1 to find A, and then for B we have 2 raised to power 1. Out of these 1 elements, out of these 1 elements in A, we have to find a subset of B. So like this, we will have 5C2 into 2 raised to power 2 up to 5C5 into 2 raised to power 5. Like this. Now, if we add this, their sum is 1 plus 2 raised to power 5, right? Using binomial expansion, if we replace 1 plus x raised to power n, where x is 2, then we will get our expansion. So this is nothing but 3 raised to power 5. But you might say, ma'am, this is only counting this case. What about the opposite case? Because they are ordered pairs, what if A is a subset of B now, not B is a subset of A? Then we just flip the order, right? So into 2. So that means we do this. 2 into 3 raised to power 5. But are we sure we are not counting any case again? What about when A is equal to B? Then we don't have to count them again because we have already counted this ordered pair. We multiplied this entire thing by 2. But which cases did we count more than once? This case, when A was equal to B, then A comma A was the ordered pair we had already selected, and now we are saying we have to select it again. We don't have to do that, right? So what will we do? We will subtract out of 2 into 3 raised to power 5. We will subtract the cases where A was equal to B, which means as soon as we got A, we knew what B was. So when A had 0 element, we've selected A and that's it. Then we know what B is. We don't have to find the subset of B. We don't have to find the subset of A to find B. We know what B is. So 5C0, 5C1 up to 5C5. As soon as we know what A is, we know what B is, and these are the cases that we counted twice. So we have to exclude it once, which means 2 into 3 raised to power 5 is 243 minus, what is this? 2 raised to power 5. So what does it come out to be? 486 minus 32, that is 454. These are the cases where A and B are subsets of each other. Out of the total ones, we have to subtract this. So finally we get 1024 minus 454, that is 570. Clear? So this is one of the ways you can do this. Of course, you can also check it directly. If A is a subset of B or A is not a subset of B, once we fix A, we have to find B from the remaining elements. So like that as well, you can do that and you will get the answer. Just make sure that none of the cases are being repeated. You have to make sure that the ordered pair is considered. Not just that we have to select 2 subsets, but we are actually selecting the order of the 2 as well. Okay? Now, let's take a look at another problem. A subset B of the set of first 100 positive integers has the property that no 2 elements of B sum up to 125. What is the maximum possible number of elements in B? Quick. The first 100 positive integers, we have a big set, and now we're taking a subset of this set such that no two elements of B sum up to 1 to 5. What will be the answer? No. Let's see. Which two numbers are giving the sum 1 to 5? Let's first think of that. You know, whenever you're stuck, just think of some examples. Which numbers do we have to take? Which numbers we cannot take together? Like that. So, which two elements? Any two elements cannot have the sum 1 to 5. Which two numbers have the sum 1 to 5? 25 plus 100. Or if we increase this by 1 and decrease this by 1. Like this, we will have until 62 plus 63. Then again it starts from 63 plus 62, 64 plus 61, that we have already considered, right? So these are the pairs, order doesn't matter, right? These are the pairs which have the sum 125. How many such pairs are there? From 25 to 62, that is 62 minus 24, 38. So out of these 38 pairs, we have to take max 1. As soon as we take more than 1 from any of these, as soon as we have, this is again pigeonhole principle, right? If we have taken 39 numbers out of these, then two of them will come from the same pair, and in that case the sum will be 125. So we have to take 38 numbers at max. We can take 38 out of these 38 pairs. Any of them is fine. You can take any one of them. It's either this or this or this, but maximum one number from each pair. So 38 from here. And the first 24, 1, 2 up to 24, you take any of them, they cannot have the sum 125. Even the largest of this, with the largest number present, 24 plus 100 is still less than 125. So you can take all of these, they will never form a sum 125 with any number present. So you can take all of them, which means maximum you can take 24, maximum 38 from here. So 24 plus 38, 62. Very good. And let's do the last question for the day. Alright, there are 5 cities A, B, C, D, E on a certain island. Each city is connected to every other city by road. There is one road that goes from A to B and B to A. There is not a different road that goes from A to B and then you have to take another road from B to A. There is one road connecting A and B. And like this, it is connected to every city and every other city is also connected like this. It's a fully connected graph. Okay. Some roads might be missing in my diagram, but you get the picture, right? Every city is connected to every city. You have a way of directly going from one city to another without having to go anywhere else. Now, what is our problem? Our problem is we have to start from A and come back to A after visiting some cities without visiting a city more than once and without taking the same road more than once. If we have been to B, let's say we took this route A to B. Now I cannot come back to A because B to A, this road has already been taken. I cannot go back on this road. I have to go somewhere and then go back. Let's say I go to C and then C to A. Now this is one such way of starting from A and then returning back to A, which means at least 2 cities need to be visited. If you start from A, go somewhere and then come back, you cannot just visit one city because you've already used this road. You cannot use this road, you have to go through another city. So at least 2 cities will be used. Now, the order also matters. It's not just that which 2 cities are you taking, B and C, but in what order? Did you go to B and then C and then A, or did you go to C and then B and then A? They are different. So how many such routes are possible? Answer is 60. Very good. Let's see how. So what do we have to, what is our problem now? Our problem now becomes that we go from A, go to some cities and come back, and we have to tell which order we are going in. So now either we can have 2 cities, we cannot have 1 cities, right? We can have 2 cities between A and A, or we can have 3 or 4, and that's it. Total 5, so that means we only have maximum 4 available between A and A, right? So now we have to check which 2 cities out of these 4. We take 2, we take 3, we take 4. Which 2 cities are we going to? And then which order we are going in? So into 2 factorial, into 3 factorial, into 4 factorial. So this comes out to be 6 into 2, 12, 4 into 6, 24, 1 into 24, 24. You add these up and you get 60. Okay, so this is a basic problem. You just have a complicated question, a complicated language in the question, but in the end the problem is very simple. You just have to calculate how many ways we can have our problem. Now it's a linear problem. Instead of a graph, instead of a complicated graph, it's just a linear problem. We have to find the cities, unique cities. You cannot go back to a city. If you visited it once, it is done. So you have to find a unique city to go to, and you have to find an order, and that's it. So with this, we are going to conclude our session. I hope you had fun. I hope you learned something. Make sure you revise all of what you learned today. You have good notes, you prepare good notes, so that whenever you're trying to revise this topic, you have all the good questions in one place that you can revise very quickly. Okay, so the next session is going to be even harder, even more difficult, because it will have even trickier problems there. So make sure you feel very comfortable with the questions we did today, very comfortable with all the theory we have done so far, and I'll see you the next time. Okay. Monty Hall. Okay, next time. We're going to discuss that next time. Bye. It was lovely teaching you. I'm seeing amazing, very promising students in the chat. You guys are very fast. You guys are giving correct answers very quickly. So I'm very happy with your performance. Just keep practicing and you'll get even better. Okay? Chalo. Good luck. Bye.